We are the surf inspection team. We have named ourselves Team Canary as well, so that's going to be for cave and navigating aircraft for research and investigation. My name is Tanner Coverstone. I'm a fifth-year mechanical engineering student. We're just going to go down the line here and introduce ourselves. So here you go.
I'm Evan Oppolt. I'm a 3-year senior.
I'm Martin Middlestadt. I am a 5th-year senior as well.
I'm Dominic Winstead. I'm a 3rd-year senior.
I'm JT Fear. I'm a 4th-year senior.
So our sponsor is the Sanford Underground Research Facility. It was built in an old gold mine. It's America's underground leading lab in underground experiments. They have a bunch of biochemistry projects to dark matter projects going on in this mine. It's just the really cutting edge of science. This is a video of the conditions within the mine. The 2 shafts, the Ore Hondo and the number 5 shafts, are the ones we are interested in inspecting. Very dark, heavy downpour of rain in these tunnels. So that's going to be a challenge for us to take care of.
We kind of put a joke in here on the slide in that they gave us a picture of the area that we're going to be inspecting here. So this isn't a video. This won't play, but it is kind of funny. It's just this black slide that we put in just because it's kind of unknown what we're going to be, what we're going to encounter. We're literally just sending an autonomous drone into one of these 5,000-foot stretches. So hopefully, well, I shouldn't say hopefully, we will deliver a project that will, or a product that will illuminate, record, and return to base so that they can post-process and have a sense of what they need. So, yeah.
So the Ore Hondo and the number 5 shafts are the HVAC system for the facility. Now, one of the shafts has a 70% block within the shaft. So they're only getting 30% of the airflow that they're sending down. So our project is to send a drone down there, inspect, see what they can do, because it's just too dangerous to send an actual person down there. These are some of the interviews because we were a I-Core project. The first one, Stan Parrish, he was an old worker in the Homestake mine. So he gave us invaluable information on how they created these shafts and their condition.
This next one, Dr. Winstead, he's a university professor at Minnesota State University, and he's had some research in the past on both LiDAR and transmitting systems with low frequency. So he gave us a little insight on how possible it is to transmit via low frequency through tunnels, and then also just some suggestions on LiDAR systems, Raspberry Pi versus Jetson Nano. That really help push us along in the project.
So our next interview is with Eric Bennett. He's the CEO of EROC, and they do a lot of cave and mine inspections. And he uses the Elio series drones and talked about the LiDAR that they have on there and the camera footage that they get back, how certain drones have a roll cage and other ones only have prop guards. So basically a whole bunch about the drones that they use. And their limitation is that they can only work with line of sight to their drone. So they generally have a technician walk along with their drone while they're inspecting and getting their data. That data then is stored on the drone. They post-process it. The reason why they can't inspect something like the surf mine that we're doing is it's too dangerous to send a person down there. So their drones, they need someone with it at all times. And in our situation, that's not possible. Now, our next interview was with Mark Bott. He's an aerial photographer. And a big takeaway from talking to him is that he uses Mavic series drones to get camera footage of different things. He said that with the smaller drones, windy conditions aren't that big of a factor. So when we're dealing with wind, it shouldn't be that huge of a deal. Another thing is when you're getting camera footage, moving slower is better because it's more stable and you get more clear video.
I will mention here, just to add on to Evan's introduction to I-Core, the program essentially consisted of soon-to-graduate engineers as ourselves allowed us to go through this program, which was kind of a brief 101 to entrepreneurship, hence why we actually went through these interviews. The last one here is going to be Ryan Thompson. He's a local electrical manager at Brookings Municipal Utilities. The reason that we pulled him for an interview is because it would be interesting to see kind of what in the local area we could actually use our drone in. So he was interested. He's been very interested this entire time with applications for both sewer inspection, storm sewer inspection, water tower inspection, basically anything that they could use a drone for that would just make it a little bit more safe so they didn't have to send people either down or up. So, but yeah, with these interviews, we actually decided to take a look into testing and what we were actually going to need to do for a drone. We needed to figure out what constraints we had because these were some very alarming and concerning interviews when people are saying that we won't have the flight time that people or that SURF was looking for, or that we wouldn't have great transmission. Thank you. Woof. So after this, we go straight into testing. So I'm going to let Martin here take over.
So our first little bit of testing that we did was the transmission system testing. Initially, that consisted of us going down to the basement of Crothers, setting up a receiver on one end of the building, and then walking with the controller just to see what we could get for range on a non-modified, just base stock cheap controller. That did not go well. I believe we got around 78 feet around a corner, which in total would be roughly 100, 120-ish feet, which, considering we need to go at least 2,000 for one of our stretches, is not looking great, but it was not ideal conditions with a open corner 90 degree, which is not something we would have to deal with, but we still were kind of anxious, so we did a little. Hello? Hello? Okay. Hello? Oh, there we are. Thank you. And then we also have been looking into low frequency, but unfortunately, after talking to Dr. Letcher, our advisor, we kind of decided that was outside of the scope of this project. So we decided to move forward with autonomous testing, which we're still leaving our minds open to having multiple relays or even multiple drones or possibly a tether-based system. So, but our main project is going to be moving forward with autonomy. So.
So when designing the drone, we need to run a couple calculations to kind of see what the wall thickness for some square tubing we would need that runs from the main hub of the drone out to the motors and the propellers. So as you can see here, we kind of alter the total working weight of the drone, just kind of get some different ideas on what the weight could be and work with that. We need to find the allowable stress for both aluminum and carbon fiber, just depending on which material we decided to go with. And we could adjust the outside side length of the square tubing. And from that, we were able to find the allowable wall thickness in order to survive that working weight of the drone with a factor of safety of 3.
In addition, we did a little bit of stress testing in SolidWorks. I guess one thing to point out is that we have a little bit of red in there, which is our highest. This is a displacement plot. However, the red will be inserted into the drone so that isn't a part that actually will be moved. Overall, this is using 3/16 aluminum, 6061 alloy. So we figured out that with 100 newtons of force, this is applied on the left side. So assuming a collision of 100 newtons kind of straight down or into the wall, we should be able to survive with very little movement. So also from testing, we were looking over at madmotors.com, and they have a lot of spec sheets on their motors and propellers and combinations of electronics. And this is one of those spec sheets. And as you can see on the far left side, they gave a percentage throttle. And so we're aiming for around 60 to 65% throttle, since this is their recommended short-term operation, meaning we will not burn out the motor if we aim for about here. That being said, we decided on a 4006 brushless motor and a 13-inch by 4.4-inch carbon fiber propeller, also from Mad Motors. With this combination, we'll need a 40 amp ESC, since it will be using 4 cells, which would be 14.4 volts.
Perfect. Thank you, Dominic. I suppose I don't think we've actually really touched on what the goals are. So let's get through those here real quick. The surf desirables here, they came to us saying that they had some mine shafts that needed inspection as they had a blockage. Due to what Evan mentioned, they had a 70% flow block. So they were interested in sending down a drone into one of these tunnels just so they can get an actual line of sight to figure out what they need to do in order to either remove the blockage or simply determine what the blockage is, things of that nature. So with that, they gave us their desirables list, and from that and the testing and interviews that we had, allowed us to kind of design our objectives, which we broke down into 2 categories here. So of the objectives list, first one is technical capabilities. We want our drone to be able to have an elevation readout, a return to home depending on battery percentage, automated flights that has the ability to use LiDAR and SLAM tech to create a point system map, as well as battery life. We are looking minimum 30 to 60 minute, but ideally we would love to hit that 120 or 2 hour time frame. So, which then brings us into our physical constraints or capabilities. We would like it to actually collide with the collision, map it out, and then be able to return with that information. So detect that blockage area. It should have a roll cage just in case if it does lose power and crashes. 360 self-stabilizing camera. It needs to be waterproof. In the video that you saw before in slide 2, I believe, you could see that there was water in the video. That was only at 1750 feet. We will be going to depths of 5,000, so it's almost a near downpour the entire time. So, and with that kind of leads us to our next slide here for our decision matrices that we based off of our objectives list. So take her away.
Yeah, so we have 7 total decision matrices, but we're just going to go over 2 real quick because these were the big 2. So for our data processing, we were looking at 3 different, basically just scales: a Raspberry Pi, a Jetson Nano, or Orin, whichever one we could get our hands on, and then a Snapdragon. Basically, we just weigh different aspects of the processor and then decided how much is it going to cost, how much or how important is the cost to us, and then just plugged all those numbers in, and we decided to go with the a Raspberry Pi. But if we do need to upgrade because we need more processing power, we will upgrade to a Jetson Nano. And then for this one, we hope to not need a roll cage at all, but we still wanted to weigh it. So we were looking at rods versus prop guards versus full cages. We decided to go with just a prop guard because it's simple. It's not going to have a large surface area to catch water or wind, and we believe it will be the least likely to get stuck out of all of our options. So
So here we just have a preliminary CAD model. I'm going to speak on kind of the materials and the frame portion of it. The frame is built out of half-inch aluminum. From the testing that we did before that JT talked about, we found that that would be a feasible option and would be plenty strong enough. In addition, there is a kind of a lid on the bottom of the shell, and that'll give us access to a lot of the electronics. All the electronics from motors, from cameras and everything will be inside of the shell.
All right, thank you, Dominic. Now, as you can see on the very top and bottom of the drone, there is a 360-degree camera, and directly under that is where you'd have your LiDAR. And the arms that would support the camera mount should not affect the LiDAR too terribly much. You'll have a little bit of dead zone, but it's so close to the LiDAR itself that the LiDAR will not pick that up. As you can also see, we have 4 legs for landing gear because we should be landing on relatively stable and flat ground. And to access the battery, which is on the bottom half of the drone, there'd be 4 latches to take that cover off. And then the LiDAR and camera would kind of just hang down underneath the drone while you could just undo the strap that holds in the battery. So with the battery being below the axis of the props, the drone should be a lot more stable as well. And with that, I'll give you back to Dominic.
So the propeller guards, as I said before, are made out of 3/16-inch aluminum rods. These will just be bent to shape. The circle around the outside of the prop guards is obviously not 3/16 rod. It would just be 3/16 thick aluminum. The reason for this is that we need our lighting to be around the outside, and that is kind of the most optimal position to put that. In addition, you can see in the side the red circle, there's a small hole in the bottom of the aluminum rod or pipe, I guess. That will be used for our wire management. So all the wires from the motor, the three wires will be routed through the aluminum tubes and then go back into the shell.
So the next 2 slides are going to be our Gantt chart. So it's basically, if you don't know what a Gantt chart is, it is just our calendar. It is what our events are going to be, what our deadlines are, and then how long we think they're going to take or how long we have for them. So this is our first semester. And then this is our second semester. So, yeah.
We've been allotted $15,000 by SURF to accomplish this project. Most of our parts have been nailed down at this point, and we have a estimated cost of $11,360. That may change slightly, but it should be very close to our final cost.
All right, perfect here. And before we start getting into questions, we just wanted to do a quick thank you, not only to the resources or the references that we used from the images at SURF, their site, but also a special thank you to Ryan Thompson from the Brookings Municipal Utilities, as well as Charlie Richer and Thad Dreets from the City of Brookings for facilitating and allowing us to test in the storm sewers, as well as a special thank you to, well, I'm going to rip this off from PBS because we thought it'd be funny, but also viewers like you, because without your guys' support and your insights after these projects, well, we would have been stagnating a lot. So we appreciate you being here. So yeah, any questions? And then before we actually ask questions, there's also going to be a QR code after this slide. If you don't feel comfortable talking now, you can always just submit that as well if you want to go to the next slide. But yeah, any questions?
Elijah.
Do you anticipate having a 12-foot radius of light affecting your battery life?
No, it should be just LED light strips.
Yeah, go ahead.
Said it was going to have 3 material going to be using the
Oh yeah, absolutely. So I believe what were we going to do for that? Was it?
So the shell's not going to be taking any weight, and hopefully it won't be taking any impact, because if it takes impact, the entire frame is just mangled beyond repair. So we're probably going to try to use something fairly water resistant in and of itself, but then we're also going to cover it with fiberglass just to nail down the waterproofness. So if we do need to, we could always just go with BLA if we're using fiberglass.
Okay, go back to your Gantt chart. Just when are you gonna have a prototype? I can't.
We should have a prototype by February.
So the question was basically, when are we going to have a prototype done? We need to have a final product done. What is that? April 1st. But we're going to try to, we are going to actually go to surf and test it there. So we're hoping to have it done a couple weeks before then.
Just a quick side note, yeah. So we don't have this on there. We absolutely should. So that's a good point. We are predicted to go out there in February to test kind of like a little box of gizmos and gadgets. So we're going to go out there with our light strips just to make sure they work before fully assembling a prototype. So that by the end of February, we are able to have this prototype ready to go. And then by April, after testing it in our own setups, by April, we'll actually bring it out and hopefully surf. We'll just be amazed with the product. So, but yeah, thank you.
What's the wattage of your lights?
The question was, what is the wattage of our lights? So
I said, well, they draw 5 amps of power, and I think they run on, is it 12 volts, 24 volts? So it'll be 120 watt LEDs. So very bright. The ones we decided to go with are 832 lumens per foot, just because we were told that that cave and stuff basically swallows up light. Any other questions? All right. Oh,
Can I ask a question? Yes. Oh, go ahead. So since you can't get people down in line, is there any plan for recovery if say you do have a crash?
so the question was if there is any plan for recovery of the drone if there is a crash. Currently, no. We're just hoping that our autonomous flight will be good enough to prevent crashing. Otherwise, it's too dangerous to get someone down there.
Surf themselves have talked about it. So kind of just referencing this image here real quick with Ore Hondo and number 5. Every time that we circled in blue is like a side entrance to that. So they have been willing to come out with nets just in case to catch it when it's that initial testing. But after that, after we, with a factor of safety, prove that it does its job and does its job well, they won't need those nets anymore when it's fully autonomous. So, but yeah. Oh yeah, absolutely. So the main issue that we had was number 5. So it's going to be this one on the right over here. I don't know if Zoom can see this, but no. Okay. The first stretch from the top to that first blue circle is 2,000 feet. That is our main issue area just for that transmission. So that's where we're going fully autonomous. And then beyond that would be pretty straightforward. It's just, again, that first distance is a little bit of a doozy. So, first step's a doozy. So. But yeah, total distance wise from top to bottom is 5,000 feet, which is, if you're not familiar, it's going to be about 5 Eiffel Towers upside down. So stacked on top of each other. So there we go. But yeah, absolutely. Yeah.
What kind of batteries are you using?
So the question was, what kind of batteries are we using? Let's go.
Yeah, so actually, batteries obviously take the most weight on the drone. So we'll be using lithium polymer batteries just because they handle the heat and cold fairly well, since our temperatures will be ranging from 95 degrees down to 55 degrees, which they can operate in very easily. Actually, batteries were a very large point of research for us. We finally found a very high capacity battery on Mad Motors, the same website we were looking at our motors and ESCs and propellers from. And it's a 4-cell, I believe it's a 10,000 milliamp hour, 28 amp hour battery. basically, and that gave us the optimal weight to still be able to get roughly a 40-minute flight time.